We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India.
Good morning friends. Today's topic higher order differential equation. In higher order differential equation, capital D equal to, we have to consider d by dx, y dash equal to dy, y double dash d square y 3 time derivative d cube y 4 time derivative d raised to 4y. Now solution of higher order. Solution, there are 2 type of solution, CF solution, PI solution, complementary fraction solution, particular integral solution. CF solution divided into part real and complex. Real also divided into part repeated and non-repeated, complex also repeated and non-repeated. So solution, there are 2 type of solutions, CF solution, PI solution. CF solution divided to part real and complex. Real divided repeated non-repeated, complex repeated non-repeated. Solutions. Number 1. Suppose d equal to -1, 0, 1, 2. That's a real number but non-repeated number. These are the solutions that is a real number but non-repeated. So real and non-repeated, then we have to write down the solution YC. CF solution. C1 e raised to m1x, C2 e raised to m2x up to infinite. Depend on the factor. How many factor is there? Suppose 4 factor, that means first 4 step we have to write down. 2 factor, then only 2 step. 3 factor, then only 3 steps. But when we have to write down, when real and non-repeated. Number 2, real and repeated. That means these two d equal to 1 1. Real and repeated 2 times. 2 2 2. Real and repeated, but 3 times repeated. So sequence first 2 terms. When we have to write down d equal to 1 1 solution, then c1 plus c2x e raised to mx. What is m? M equal to 1. We have to consider it. And 3 times repeated, then we have to write down 3 step of first sequence, c3 plus c4x plus c5x square, and m equal to, that is e raised to 2x. Why we have to start c3? Because of c1 and c2 we have to consider previous. So we have to consider c3, c4, c5. Number 3, complex solution. When complex solution, that means we have to use when delta less than 0, then we will get complex solution. Delta greater than 0, then we get real solution. But delta less than 0, then complex solution. That time we have to consider I square equal to -1, and complex solution, this type of solution we will get, that is a complex, d equal to m plus ni. M is a real number, n is a imaginary number. So real number, that means I is not available, so we have to write down in exponential function e raised to mx. N imaginary number, I with multiplication, then we have to write down cos and sine function, c1 cos nx and c2 sin nx. Number 4, complex and repeated. Complex and repeated, that means same solution, but repeated, then we have to use here single constant, we have to consider it, non-repeated. But in repeated we have to consider as a sequence, but it is depend on how many time repeated. Suppose 2 time repeated, then we have to consider first 2 term. 3 time repeated, that means we have to consider first 3 terms, c1 plus c2x plus c3x square. Okay, and as it is cos nx and sin nx, we have to write down. So CF solution, 4 type of solution: real non-repeated, real repeated, complex non-repeated, and complex repeated. Now we have to consider some examples. Y double dash minus 2y dash plus y equal to 0. Right side is 0. That means we have to find only CF solution, complementary fraction solution. So why we are taking common? So y double dash, then square y dash dy and y. Why we are taking common? Because of capital D equal to d by dx, not dy by dx. Now we are taking y common, so d square minus 2d plus 1 bracket complete y equal to 0. So d square minus 2d plus 1 equal to 0. It is a perfect square form, d minus 1 whole square. That is a d minus 1 2 times. So d minus 1 equal to 0. So we will get d equal to 1 and 1. So yc equal to, it's a real and repeated, but 2 times repeated sequence, first 2 step we have to consider it. So c1 plus c2x e raised to 1x. Another problem we have to consider is y 3 time derivative minus 2y double dash plus 4y dash minus 8y equal to 0. It's a 4 term is there. So first we have to convert in higher order form. So d cube y 2d square y 4 dy minus 8y. Y we are taking common. So d cube minus 2d square plus 4d minus 8 bracket complete y equal to 0. D cube minus 2d square plus 4d minus 8 equal to 0. 4 term is there. Whenever in the question 4 term, then you have to first check divided into 2. If any one common factor, then directly we have to find it. So first 2 we have to take common d square. So remaining factor d minus 2. Here we are taking 4 common, so d minus 2. So common factor is d minus 2. So directly we are taking common factor d minus 2. Another factor d square plus 4 equal to 0. D minus 2 equal to 0, d square plus 4 equal to 0. Plus 4 we have to shift right side, that is minus 4. It's a less than 0. So square root is not possible. So we have to consider I square equal to minus 1. So minus 1 equal to I square, so 4I square. Now we have to find square root of d equal to plus or minus 2y. That is a d equal to 0 plus 2y. Another solution d equal to 2. This is a real non-repeated. This is a complex and non-repeated. So first we have to write down the solution of real non-repeated. Second we have to write down complex and non-repeated. So c1 e raised to 2x plus e raised to 0 because of exponential form, because it is a real part and it is a imaginary part. So e raised to 0x c2. Why we consider c2? Because c1 we have to consider it. So c2 cos 2x and c3 sin 2x. Another problem, y double dash minus y equal to 0. So higher order form d square y minus y equal to 0. Y we are taking common, d square minus 1 equal to 0. D square minus 1 equal to 0. A square minus b square formula we have to apply here. A minus b, a plus b, d minus 1, d plus 1 equal to 0. So d equal to 1 and minus 1. It's a real and non-repeated. So yc equal to c1 e raised to 1x and c2 e raised to minus 1x. So this is a CF solution. Whenever right side equal to 0, then we have to apply only for CF solution. Do not apply PI solution. Now if right side not equal to 0, then we have to find also PI solution. CF plus PI. PI solution, particular integral solution. Divided in 3 parts. If Rx is equal to exponential form, e raised to mx. If Rx is equal to cosine form, cos mx sin mx. If Rx is equal to variable form, x plus 1, x square plus 2x plus m, anything else. When exponential form, then we have to consider d equal to a equal to m, d square equal to a square equal to m square, m is a coefficient of x variable, d cube equal to a cube equal to m cube, d raised to 4 equal to a raised to 4 equal to m raised to 4. Cosine form, that means only d square equal to minus a square equal to minus negative m square. Okay, not d cube. D cube, that is d square into d, that is minus m square into d, we have to write down it. Variable form, then we have to apply two formula, 1 plus d inverse and 1 minus d inverse. 1 plus d inverse is equal to 1 minus d plus d square minus d cube up to infinite. 1 minus d inverse, that is a 1 plus d square plus d cube up to infinite. Now we have to consider some examples. Y double dash minus 4y dash plus 4y equal to e raised to 3x. Right side is not equal to 0. Is not equal to 0. That means we have to find CF solution plus PI solution. So first we have to write down in higher order form d square y minus 4 dy plus 4y equal to e raised to 3x. Y we are taking common, d square minus 4d plus 4 e raised to 3x. For CF solution we have to consider it 0, d square minus 4d plus 4 equal to 0. It is a perfect square form of d minus 2 whole square. So d minus 2 equal to 0. So d equal to 2. It's a real and repeated. Real and repeated, that means a sequence first 2 time repeated. So sequence first 2 term we have to consider it c1 plus c2x e raised to 2x. Now we have to find yp. Yp equal to, it is a multiplication form. When we have to shift in right side, then division form. So yp equal to 1 upon d square minus 4d plus 4 e raised to 3x. Exponential method we have to apply. What is exponential method? D equal to a equal to coefficient of x variable 3. So 3 we have to apply here, 3 square minus 4 into 3 plus 4 e raised to 3x. 3 square 9, 4 3 12 plus 4 e raised to 3x. 9 plus 4 13, 13 minus 12 1. So 1 by 1 e raised to 3x. So yp equal to e raised to 3x. So y equal to yc plus yp. So CF solution plus PI solution. So this is the solution. So whenever right side not equal to 0, then we also find CF and PI. Another question we have to consider it, y 3 time derivative minus 6y double dash plus 11y dash minus 6y equal to cos 2x. It is a cosine method. So first we have to write down higher order, d cube minus 6d square plus 11d minus 6 y equal to cos 2x, d cube minus 6d square plus 11d minus 6 equal to 0. First two term, last two term, first two term d square common d minus 6, but here last two term d minus 6 not a common factor. So here we have to use the table method. So sum of coefficient of d cube, that is a 1, d square minus 6, d 11 and constant minus 6. So 12 minus 12 0. So d minus 1 is common factor. If not equal to 0, then d plus 1 common factor. D minus 1 equal to 0, d equal to 1. Now table we have to consider coefficient of d cube 1, d square minus 6, d 11 and d constant minus 6. Here we have to consider 0 and we will get 0. So 1 plus 0 1, multiply with 1 that is the factor. So 1 into 1 1. 1 plus 0 1, 1 into 1 1. Here we have to write down minus 6 plus 1 minus 5, minus 5 into 1 minus 5, 11 minus 5 6 ones are 6, that is 0. So equation in cubic form, then this table method we have to write down is reducing, that is a quadratic form, coefficient of quadratic equation. So 1d square minus 5d plus 6. So now the find factor of 6, we will get 5. So 3 2s are 6. So d minus 2, d minus 3 equal to 0. So the factor d equal to 1 2 3, that is a YC CF solution, non-repeated, real and non-repeated. So C1 e raised to 1x, C2 e raised to 2x and C3 e raised to 3x. YP 1 upon d cube minus 6d square plus 11d minus 6 cos 2x. Here cosine method. So cosine method we have to consider d square equal to minus a square. So a equal to 2, that is a minus 4. Only d cube, that is a d square into d. So d square, that is a minus 4. So minus 4d. We have to apply here. So 1 upon minus 4d minus 6, d square equal to minus 4 plus 11d minus 6 cos 2x. Minus 4d minus minus plus 6 4s are 24 plus 11d minus 6 cos 2x. 11d minus 4d, that is a 7d, so 24 minus 6 18 cos 2x. Linear equation, not a quadratic form. So cosine method only d square we have to apply the value. So we have to convert in d square form. How? It's a multiply with conjugate. So 7d plus 18, then it's a conjugate is 7d minus 18, 7d minus 18. We have to multiply it 7d cos 2x and 18 cos 2x. 7d a plus b, a minus b, so 7d square, for 7d square matlab 49d square and minus 18 square. So multiply 7d cos 2x, 18 cos 2x, 7d square, that is a 49d square, 18 square 324. Now d cos 2x, that is a derivative of cos 2x function. So derivative of cos 2x, that is a minus 2 sin 2x. So minus 14 sin 2x. Minus 18 cos 2x and d square equal to minus 4, we have to consider it minus 4 minus 324. So minus 14 sin 2x minus 18 cos 2x upon 49 into 4 minus 196 minus 324. So minus 14 sin 2x minus 18 cos 2x by minus 520. So this is just now YP. Now we write down y equal to YC plus 5a. So first we have to write down CF solution and plus particular solution. So this is a solution of CF and PI solution. CF and PI solution. Thank you very much.